In this video, I would like to give you a brief tutorial on how you can plot the data from your recent accelerated motion lab on Logger Pro. So here we have one of the groups that had done the lab with the wheel and axle shown in this picture over here on the right. And they plotted the position of this wheel and axle as it was rolling down the rods. And you can see that they've done it 3 trials and they've averaged them over here. So I'm going to take this data here and I'm going to copy and paste it over in Logger Pro. So I'm going to highlight that table, Command C, and then I'm going to open up Logger Pro and we're going to put that data over here. So Command V. Okay, you can see that the X was, if we look back at our data, was position, time, and the vertical axis would be distance traveled or position. So we're going to change our axes. Our X is now going to be changed to time, short name T, seconds. You can see it's changed at the bottom here. And on the vertical axis, we're going to put position, short name is X, and the units are in centimeters. Now, for curve fitting here, you can click on the curve fit button, and hopefully we talked about this in class. You can see that this looks like a bit of a quadratic. So we can fit a quadratic function on here and click on try fit, and voila, there you go. There's the graph, and you can label this. The title is going to be position versus time. And let's make sure that it's only point symbols that are showing up. And let's make sure our axis starts from 0 for both X and Y. And so there we go. That's our position versus time. Now, as you can see in this graph, this is not linear. So we need to linearize our data. So if you go back to our Chapter 1 notes and scroll through there till we get to the section that is on curve fitting. And so you can see that we obviously do have a relationship. It's not linear, and it looks like it's similar to this one. Looks like we have a quadratic relationship between the position and the time. So the y variable, which is in this case position, is proportional to the square of time, t. So in order to linearize it, we need to graph the y variable versus the square of the x variable. So we have to plot x, because that's what's being plotted on the vertical axis. And then instead of on the x-axis, we're going to be plotting the square of time. So what we need to do is we need to create a column that is going to be the square of all these times. So we go up to the Insert tab at the top, or actually not the Insert, the Data tab at the top, and we go to New Calculated Column. In our calculated column, we're going to call that time squared. Short name is going to be T to the power of 2, and the units are going to be in seconds squared. So in the expressions button, we are going to be squaring the time variable. So we look for the time variable, and then we square it. We can do a Shift 6, which gives you that caret symbol, and then 2, and click on Done, and you can see that you get the square of these times. So you can see over here that the square of 0, 0, square of 2 is 4, square of 4 is 16. So we're going to insert another graph. So we go into Insert Graph and Command R to auto range. We need to change the variables appropriately. We actually don't want time square on the vertical axis. So if you click over here on the vertical axis title, you can change it so it's back to position. But on the horizontal axis, we're going to be putting not time, but time squared. And then we'll auto scale this, or you can go to your axes options and change it auto scale from 0. And you can see that this looks like kind of a rough straight line. So I'm going to click on linear fit, and we can see that we have a line of best fit, and it's pretty strong correlation of 0.9987. So the other thing that we'll do, let's put a title in this lab as well, or this graph. This is going to be position versus time squared. Okay, one more thing that I asked you to do in this lab was to plot the velocity versus time. So to do this on Logger Pro, we're going to be taking, if you recall, velocity is the change of position over the change in time. So if we're going to find the velocity for, say, this interval from 0 to 2, we're going to have to take the displacement, which is 2.833 minus 0 over 2 minus 0. So let's create another column under data, new calculated column. We're going to call this column the average velocity, or you can call it simply the velocity. But technically it's actually an average velocity. Short name is V, and the units are going to be in centimeters per second. And then under the variables, this is something new. We need to take the change of this over the change of that. To do that in Logger Pro, under the functions button, there's something called delta. Delta basically takes the difference between two consecutive points in our column. So if we click on delta, and then in that brackets, you say position, then you're finding the displacement. You're taking the difference between these two values and these two values and so forth. And then outside of the brackets, we'll put the divide sign. Then under functions, we're going to put in delta. And now under variables, you're going to put in time. So you're finding the change in position over the change in time. You could have also just put 2, because you can see that the change in time every time is always 2 seconds. So I'll click on done, and I get the velocity. So we can insert another graph in here and go Command R, and we got a velocity versus time. And if I auto scale this from 0 for both of them, yeah, it looks like it. Well, it doesn't look like it's auto scale from 0. No, it isn't. Auto scale from 0. Auto scale from 0. That is not working correctly. Let me change that to manual and make that 0. And then we'll change that to manual and make the bottom 0. Okay, so you can see that graph. Now we can put a line of best fit, and that's great. You can see this linear relationship between velocity versus time. But I have to admit that this has a flaw in our data. You see, when we were taking the slope of this line, we were finding that delta x over delta t between two consecutive points. We were plotting that velocity here at a time of 2 seconds. We don't want that at 2 seconds. Actually, that velocity is an average velocity, should be really plotted at the average of that time interval. So it can't be plotted at the end of the interval or the beginning of the interval. It should be plotted at the average of that time interval. So we're going to go to data here and do a new manual column, or you could do a calculated column. It's really up to you. So let's say I just do new manual column, and we're going to call that time. I'm going to just distinguish between the other column I had over there, which was time, and just use a capital T time, because the other one I was using with a small t, and I don't want to mix them up. So the short name is still going to be the same symbol t, and the units are in seconds. And we'll just click on done. So what we need to do is plot this time. If you can see the table maybe a little bit larger here, you can see what I'm talking about. That time cannot be plotted, that velocity here cannot be plotted at 2 seconds. We want to plot it at the average of between 0 and 2, which is 1. And the next one would be between 2 and 4, which would be 3, 5, 7, 9, 11, 13, 15. I guess I could have auto-generated the values, by the way. But that's it. And now what I need to do is go back to my graph and change this time column, this time axis here, and use the other one. You can see that as I switch them, they've just been moved just a little bit to the left. So you can see that the new velocities are not being plotted at the beginning or the end, but it's being plotted in the middle of the interval. So here we have the time of, let's say, 1 second, and it's being plotted at 1 second, not 2 seconds. So all we need to do here is put a correct best fit line on it. Here we go. And there, now we have the correct best fit line for the velocities plotted at the average times. And then, of course, you can add a title to the lab or to the graph, which I've just added. Okay, that's it.